Swayam Prabha. Digital India. Educated India.
So today it's going to be a very different session. It's going to be in this completely different area of cloud, edge, and fog computing for IoT. And so cloud computing, as we know, it has already existed for quite some time now. But recently, there has been a lot of emphasis on edge computing and fog computing. We'll see how these are similar, but not exactly the same. Um, and we'll see different flavors of edge computing also. So that's going to be the broad topic that we'll discuss today. Yeah, feel free to stop me anytime to if you have any questions. Okay, so outline of today's talk, we'll kind of break it down into two for the two sessions. We'll break it down into two parts. So we'll start with cloud computing. We'll go through the basics of cloud computing, what some of the internal architectures, and some of the challenges we face there. So we'll cover a lot of cloud computing aspects in the first session, and we'll kind of motivate as to why cloud computing has issues when we look at Internet of Things. And that's when the aspect of edge computing comes into picture. And so in the second session, we will look at edge computing, some of the details of its characteristics. There are various flavors of edge computing that you can see, that is fog computing, cloudlets, mobile edge computing, and so on. And we will then kind of understand it a little bit better using some examples. Yeah. I'll kind of at the end of this, I'll try to motivate you with some very uh, interesting and very widely currently very hot areas of research in this topic. So anybody who is interested in research also would be interested to hear that. Um, so yeah, so that's going to be the outline of today's talk. So let me, without any delay, get into what cloud computing looks like. So I'm assuming everyone has heard what cloud computing is, right? That is something that is been there for quite some time now, and everybody would have at least heard of it if you don't know the exact details of how it operates. Cloud computing, there is an evolution, and we will look at how we came to cloud computing. There is a very you know very well defined evolution of how cloud computing came about. But to give you an introduction, cloud computing, as you can see, is it basically allows various users who are using different kinds of devices, let's say PC, laptop, smartphones, or whatever it is, to access some services or some resources via the internet, and they access it from a remote location, right? And these remote locations are typically, you could call it cloud, and they are actually data centers. That's how the cloud computing, um, uh, basically the whole flow of data happens there. But formally, if you define cloud computing, it is a, it is a style of computing where the resources that you get from the cloud they are provided as services. Yeah, so there are different kinds of services that are provided by the cloud, and these resources are these resources could be hardware resources, or they could be even software services. And if they are some hardware resources, they are typically virtualized. So if you don't know what virtualization is, it is nothing but there is a large pool of resources or hardware that is available, and they are provided. So there are physical resources available, and they are grouped into logical resources, and then every user gets a logical set of resources. So basically, there are the same set of physical resources which are shared among multiple users. Yeah, so that's what virtualization achieves. So this is a style of computing which uses this virtualization technology, and virtualization is one of the enabling technologies for cloud computing. And this virtualization is then used to provide resources in a shared manner to different users as services over the internet. And one of the interesting things about cloud computing is that you can dynamically scale the resources that are provided to user. Yeah, so it's dynamically scalable. So that's one interesting thing. And you have to remember for the time being that this dynamically scalable part is something that is valid until there are lots of users trying to access it. That is human users. Now that also has come into question as we get into the IoT era. Yeah, so that is one thing that needs to be kept in mind. So there are these different resources that are available, and they are available in these so-called data centers. And any user, if he wants to access these resources or services, they can access, and there are particular ways of accessing it. It's of course you have to pay, uh, and there is a pricing mechanism that's associated with it for you to access. So the advantage of cloud computing is that there is a very significant savings in terms of cost. Yeah, because now the user, or the let's say some organization does not have to set up those. They don't have the startup cost, so to say, to set up the infrastructure for computing. Yeah, so they can pay. Of course, they have to pay something, but they can pay and access those services from a third party provider, and that is much more cheaper than setting up your own infrastructure to do that. So that's one of the advantages that's there for cloud computing. It is also pretty much known to be highly available. That is, there is a lot of redundancy mechanisms. There are mechanisms that are there in place to make sure that the services are available round the clock, and you don't face too much downtime. But it's something that is not entirely guaranteed. So sometimes we do hear that some of these cloud providers are down, and then you're not able to access some of these services from them, right? So that is possible. But the one of the things that is tried to maintain in cloud computing is that there is a high availability of resources and services. And of course, scalability is the other advantage. So now you have a large pool of resources. So as and when a user wants to derive more performance by accessing more resources, the cloud provider can there can be an automatic way of scaling the resources so that the user sees the improvement in the performance based on even the increase in the amount of workload that the user may want to execute. These are some very well-known advantages of cloud computing. We will look at some of these aspects in terms of how these services are accessed and what are the resources that you access from the cloud. So before getting into that, as I mentioned, there is a very well-defined evolution of how cloud computing came into existence, right? So here is this is what shows that. Um, yeah, so as you can see, this first phase that was called the mainframe computing phase, where every user had a so-called dumb terminal. So basically, everything that every intelligent execution that needed to be done was sent to a mainframe computer, which had a large amount of resources, and you could execute your tasks in terms of jobs, and once you have the result, then it's sent back for consumption. So that was the initial way of how computing happened. Then the PCs, or the personal computers, started becoming more and more powerful, and then that led to an era where it was no longer required. As they became more and more powerful, they became also equipped to handle tasks that required a lot of computation. So you could do a lot of intelligent things on your personal computers itself. So that's the second phase, which is called the PC computing phase. But then that still did not exploit the full capability of how computing could be scaled. So that's when some researchers thought of connecting your the personal computers, laptops, etc., to uh, some other high-end machines or servers or other PCs using local area networks. Yeah, so there were local area networks that were used to connect these machines, and that came to be known as the network computing phase. Um, yeah, so this of course made it quite the flex there was a lot of improvement in terms of what could be done, how things could be scaled in terms of computing. But we could go further, right? Why stop at one local area network? Yeah, so then people started connecting uh, different local area networks. Yeah, so multiple networks, small networks in local areas started getting connected, and that came to be known as the internet. So now we you can see the full potential in terms of connecting things all over the world. So that phase was called the internet computing phase. um, but still, there was some limitation there as well, in the sense that things still existed in terms of uh, the exact terminology would be there wasn't really a lot of distributed mechanism available. So things had to be sent to some remote location. If you wanted to offload or send some computation somewhere, then you had to send it to a remote location, run it, and then get the results. But there came this next phase where things got a little bit more distributed. So the grid computing phase is such a architecture where the computing itself became quite distributed. So you had different PCs in different networks, and you could actually distribute a particular computation workload among these different machines, and that came to be known as the grid computing phase. And finally, of course, grid computing has its advantages, and that also makes it quite complex to manage manage the resources in the architecture, because now you have to decide how to allocate resources in this large distributed architecture, right? So that was one of the challenges there. Then came cloud computing, and it's a client server architecture. It's a centralized architecture, right? So you have a large pool of resources that is located in a particular place, and you as a user, using any of these machines like PC or mobile device, could access a set of resources from this cloud. Uh, but um, but you have to remember, in terms of if you compare it with grid computing, it's still a centralized kind of architecture and not a distributed architecture. Yeah, so that's the key difference between grid computing and cloud computing. And it is a little bit different. You may think that it kind of is similar to mainframe computing, but one of the key differences is that there is the amount of resources that are available in cloud computing are much larger in comparison to the mainframe computing phase. And of course, there is this enabler virtualization, which is also a part of cloud computing, which makes it quite seamless in sharing the resources. Yeah, so that gives a wide picture on how the evolution of cloud computing came by. Now let's look at the architecture of cloud computing. So as we know, as we have already heard that there are lots of services that are provided to users, and these services can be of any type. Yeah, so based on what kind of services you are requiring, the cloud computing it has a layered architecture, and you can find different kinds of different kinds of services provided by different layers in this architecture. So if you look at it, there are primarily three layers to it, but you can also have some extra layers that we look at. Firstly, I would talk about this layer called application, which is also called as software as a service layer. So if somebody hasn't heard of this already, it's quite popular, and anybody who has heard of cloud computing should also have heard of this. But typically, what software as a service allows is you can actually, so what has cloud computing now done for user is that instead of having all those resources or applications running on their own device, they can now run it on a cloud, right? A set of nodes that are remotely located, So basically, you can have applications that can be run remotely, or you can have a set of hardware resources that you can access from a remote node. So that's where the SaaS, software as a service, comes into picture, where the users can now run the applications remotely. Yeah? So this part of the architecture of a cloud only provides to the user the application. So if you want to run some application, this is what is a service that you will request from the cloud, and the cloud would there are multiple ways. Again, the software as a service can also be provided. So we'll just briefly look at that as well in a later slide. So then that's only the application part, right? So now you can also access more services, right? So one of the other things that you can access is called infrastructure. And in infrastructure as a service is another layer of this architecture. What is done here is you are not only here you're not asking for the application, so to say, but you are asking for the computing resources. Yeah, so you're now asking for these set of resources that are virtualized on a set of nodes that are available in the data center, and you will get a logical set of resources from the that are derived out of the physical compute nodes that are available in the data center. So this is what comes as part of the infrastructure. It's the compute resources. So it on not does not only have compute nodes, that is processing resources, but it also has storage resources. It also has some network resources. So all of these combined together can form the infrastructure as a resource, as a service, that is provided by the cloud provider. So of course, when these things are provided, one of the things that needs to be ensured is that there is a guaranteed level of processing that is provided by the cloud provider. And it's not just about processing, but you also need some bandwidth reservations that need to be made, so that the amount of data exchanges that happen can be done without too many delays. There is a certain level of service that also needs to be provided, and that's part of the service agreements that are made between the cloud provider and the user. So moving on, we can add a little bit more to this infrastructure as a service, which is adding things like an operating system, so you add an additional stack over this. That's the OS, and also there are some other set of service applications that you could add as services. So basically, you build a software stack on top of the hardware resources that are available as infrastructure as a service, and that forms a kind of service that is called as platform as a service. So that's going one step further. So now you can have the entire stack, from hardware to the OS, to some set of applications that you want to access, run on your cloud. Yeah, so that this kind of service can also be accessed from the cloud. And finally, there is also this there is this additional service that also is available, which is called data storage as a service. Yeah? So it means that now we are not thinking about computing, but we are more bothered about the storage aspect. So a consumer may need only some amount of storage from the cloud, and that's the service that it requires. So that's the service that's called as data storage as a service. And it of course does not only include the storage part, but also it needs some bandwidth associated with it. So so that storage, the whole process of storage and retrieval happens in good time. So that kind of summarizes how a cloud architecture looks like, and what are the kinds of services that you can avail from the cloud. So this is that it's because there are these different layers, that's why it's called a layered architecture. Yeah. So any questions until now? Okay. Yeah, please, if yeah, I'll
Yeah,
kind
you
of.
could unmute and ask, or put your questions in the chat. Anything is fine.
Okay. So yeah, I'll periodically kind of look at the chat and see if there are some questions. Otherwise, you could also ask. Okay, moving forward then. Um, So just to give you how these layers look like, let's kind of start with the easier one, which is the application software as a service. What the architecture now looks like this. So on premises, or on in some office setup now, you would have these users, which would be the users would be using some browser as a client, and they would be accessing the application which is actually running on the cloud. Yeah, so this is one kind of software as a service that we see quite a lot. This is a very typical software as a service that is encountered. Now there is another kind of software as a service that is also possible, and here is a situation where the user is actually running some application on the device that he or she may be using, and that application may seek some extra functions, or extra some set of you know application stubs, or whatever that is not there in the application, the version, or the part of the application that the user is executing locally, may be accessed from the cloud. Yeah, so that's also one kind of software as a service. And here, um, so one of the examples here is your Apple iTunes, let's say. So there you have uh, lot of audio, lot of media files that you have, and there may be some uh, media file that you don't have on your application, and but you want uh, that's something that you want to access, and that's part of the cloud. So there may be some other functionalities that are available also, that could be accessed from the cloud, that is not part of the application already. So there are some scenarios like this as well, where you can have the software as a service kind of setup. Now, the platform as a service, as I already mentioned in the previous slide, it's as we remember it, it's this infrastructure as a service plus the OS and some required services, right? So that is what this looks like. So you would have a lot of the infrastructure, which is the scalable infrastructure, including the compute nodes, storage, and network resources. And you may also have other set of applications, including the OS. Okay, so there could be an entire integrated development environment also that's available, where things can be where new applications can be developed. So the platform as a service will also provide you other functionalities like data security, because security is one major concern in cloud services. So data security is is an important functionality that needs to be provided. There can be mechanisms that are in place for backup and recovery. Yeah, so assuming that some execution was happening, and suddenly the node on which it was happening fails, so there needs to be some mechanism to recover the computation. And so that's where backup and recovery come into place. And there can be various kinds of applications that are hosted. So you can have this entire stack as part of the platform and, as a service. So this is how internally these services would look like. Okay, so with that understanding, so we have gone through what is cloud computing. We have seen what are the different architectures in cloud computing. I mean, the different layers in cloud computing. And we have also seen in terms of evolution how cloud computing came into existence. Now, we have to also look at the different types of cloud computing. And here it is more, you know, the, the, the different types are in terms of how they are accessed. Yeah, so how they are available to the user. The three types of cloud computing that are that are used in various scenarios are public cloud, a private cloud, and there's something called a hybrid cloud. So public cloud is nothing but the scenario where you're actually, there are these multiple users which are actually asking a third party cloud service provider some resources or some services, like we already saw. Yeah, so that is public cloud, whereby everything, every service or resource that you're trying to access is remote. And so it's external to the cloud. It's an external cloud, so it's not something that is part of the setup where the user is located. Yeah, so that's the public cloud. So the computing resources, once the user asks for some service in the public cloud, this third party provider, which is an offsite third party provider, would allocate some resources and provide whatever service the user wants. And one of the things that could happen there is, which is quite natural, that there are multiple users now trying to access some service from the cloud. So there could be applications from different users that are mixed together in the cloud, right? So if you remember that they are given virtualized set of resources, and there can be sharing of resources that are seen, right? So when there is sharing of resources, there can be applications that are mixed together and executed within the cloud. Yeah, so you can have a couple of applications that are running on the same set of they could be sharing some physical resources while executing. Yeah, but of course in a virtualized fashion. So that's something that the public cloud would have. Also, going a little in the other direction from public cloud, you can see something called the private cloud, which is internal to an organization. So basically, this is a type of cloud computing which is built exclusively for a client. Yeah, so there is one organization which wants cloud technology to have store some of its very private information, that private information of the organization. And in that situation, it may not be feasible to send the data or do any computation by accessing services from a public cloud. And that's where the private cloud comes into picture. So the advantage of having the private cloud is, there is full control of the data. Yeah, because now the data remains within the purview of the organization. So that there is absolutely no possibility of data being tampered with by somebody, some unknown entity. um, Although cloud providers are supposed to also take care of these things, but still there can be breaches. So security, of course, is also something that can be now taken care of by the uh, user or the organization itself. And there is, as opposed to what would happen in a public cloud, where if you're asking for a service, there is a agreement that is made between the user and the cloud provider based on how much you pay. There is a certain level of quality of service you get. But in the case of an private cloud, that is not too much of a concern, because you get full quality of service, right? You're not there is no such mechanism of giving quality of service based on how much person pays, right? Because it's completely owned by the organization itself. That's the advantage that you have. But of course, that the overhead that comes into this kind of private cloud setup is that the company or the organization itself has to now manage and build this cloud, right? So it's as I mentioned in an earlier slide, the onus of setting up this infrastructure is now on the organization. And there is a lot of overhead in not just setting it up, but managing it over a period of time. So that's the burden that comes with it. But of course, you get some of the other advantages that you may have to forego in the public cloud scenario. And finally, there are you can have best of both worlds kind of scenario if you are using something called as the hybrid cloud, whereby you can have certain things put into a private cloud that you want to maintain, and some of the aspects you can push to a public cloud. Yeah, so there may be some information or some kind of applications that you want to run which are not very critical, and it's okay if there are some if some external entity somehow has access to it. but there are uh, there is some information that or that an organization may not want to reveal in any manner, right? So that those kinds of scenarios, you may want to use something called a hybrid cloud model, and that gives you both of these things. So you will have full control on things that you uh, deem to be important, and you will let go of the control and also some burden of maintaining a very large cloud infrastructure by sending some of the unimportant data to the public cloud. Yeah. So that of course gives you some flexibility, but one of the interesting things that happens here, as in the case of distributed setup, is that now there is this challenge of determining how to distribute your applications. Yeah. So you have to find out what are those specific applications or parts of applications, or types of data that you want to have as private, and or you want it on a private cloud, and the ones that you want on the public cloud. Now, how do you distribute this is a very um, uh, interesting question. I mean, there could be several techniques to do this. Some could be, very static mechanisms of doing it, like you decide upfront that this is how the distribution that's going to be, and you distributed it accordingly. But there could be very dynamic ways of doing this as well. So therefore, there are very interesting challenges there of how to distribute this set of applications among the various kinds of types of clouds. So let's look at let's look at something, some features of cloud computing. I mean, we have looked briefly touched upon them in some of the earlier slides, but let's focus on them now, because some of these aspects are quite important. They seem to be advantageous in terms of a scenario where where a user via his desktop or laptop is trying to access some service. In that scenario, there are some features that the cloud computing provides, and once we look at it, then we will go on to see what may be some of the issues with cloud computing, and that's where the motivation for fog and edge computing comes into picture. So as we have seen, there is a scalability in cloud computing, and there is also something which is known as on-demand uh, you know provision of services. So services, if there are some services requested from the cloud, there is an on-demand way of providing the resources and executing those services on the cloud. Yeah, so it's an on-demand mechanism, and of course, scalability means that based on your uh, requirement at a particular point in time, and the kind of agreement that you have with the cloud provider, your resources could be scaled. Yeah, and assuming that you were using in terms of virtual machines terminology, let's say you were using a couple of VMs to execute some very large workload, and that workload became was scaled to some high performance kind of scenario, and then these two VMs are not enough. You require more than two VMs in that scenario. it would be possible to scale the resources. Also, you could scale it over several data centers. Yeah, so there is a lot of scalability option that's available in terms of cloud computing. The other aspect that's also true about cloud computing is that it provides this user centric interface. So the user can now access these services either by internet browsers or web services that are available. So it's more in a user-centric approach of providing these services. So that's one feature that cloud computing has. As we have already talked about quality of service, right? So one of the things that cloud computing strives to achieve is every user, based on the agreement that he has, there is a certain level of quality of service that is demanded, and the cloud provider has to guarantee the level of quality of service that the user has asked for. Guaranteeing quality of service means that, let's say we take an application and executing an application. The contract is that every GB of data needs to be processed within some X amount of time. Okay, so that if that is the scenario, then that QoS is guaranteed in terms of whatever resources are provided by the cloud provider. So it is the owners of the cloud provider now to choose what are the resources required, and how much resources are required to guarantee these set of these service level agreements that are that need to be ensured for the user. Yeah, so it could be in terms of how much CPU performance you want, how many sets of cores you want, the bandwidth that needs to be there for exchange of data, what is the memory capacity that is required to run these applications or access the platforms. So all of these things are part of the cloud computing framework that and a provider has to ensure this. And this is where the part of pricing comes into picture. So as we know, nothing is free. There is some cost that is incurred. So you're saving on the very huge cost of not setting up the cloud infrastructure, and you're seeking that service from a third party. So there needs to be some benefit for the cloud provider as well, and that's where pricing mechanism comes into play. And so every cloud provider has a pricing mechanism, be it in terms of the data that you transfer between between your device and the cloud node that you use, the amount of or the capacity of the node that you want. So all of these things play an important role in deciding what is the price that you pay for accessing these services. So there are if you look at Amazon, Google Cloud, and various such services, you can see that there are they price their services, and they have a fixed pricing. There are various kinds of pricing mechanisms that are set whereby users can access different kinds of services. So there may be some services which have free access. Even if you see on some of these well-known cloud platforms, some services may be absolutely free, so you don't have to pay anything. But there can be some other services, or there may be services where up to a certain quantum of data it is free, and then after that it becomes chargeable. And so there can be various such pricing mechanisms that are there, and that's part of the cloud computing setup. In terms of pricing, there are three dimensions, as I already mentioned, that are taken into consideration. Storage is one aspect. So you have to pay for the storage, the amount of storage resources you access based on the amount of data that you want to store. And it typically is in gigabytes and over a monthly period. Yeah, so that's one dimension of the pricing. There are bandwidth resources that you want, so it's not just storage or compute, but you also need to transfer data in and out of the platform service that you are trying to access from the cloud. So if you have to do that in the strict amount of time that you are willing to spend for doing it, then bandwidth is an important criteria that needs to be satisfied. Yeah. And then there is compute pricing. So it could be based on how many cores you want to access for how much time. So that could be one way of determining what the compute price is. So as is mentioned here, you could be charged based on the time units that you need to run an instance, or it could be running an entire application, or you could also maybe based on whether you're accessing an entire set of resources for servicing your request. So compute basically involves how much time you need to access those resources. So it's a very interesting scenario, and there are a lot of research works also that have been done in this area, where people have tried to optimize how we can allocate resources to multiple users, such that the pricing the total price can be minimized. Yeah, so that the users are not charged too much. So there can be the allocation also plays an important role in deciding the pricing. Yeah, so there are some interesting trade-offs that can be looked at there in how we can allocate these resources so that these prices can be minimized. Yeah, so moving on to the challenges in cloud computing. So one of the very negative aspects that people do ask about in regarding cloud computing, which people think about as an aspect which is against cloud computing, is this performance aspect. In the performance aspect, the issue is that the users typically could be located very far away from these cloud providers, which result in excessively long latencies. Yeah, so if I don't know if you have in your previous session on IoT applications, one of the things that you may have seen different IoT use cases or applications. One of the things that you may have looked at is the various kinds of applications that are there. The nature of these applications, they may require different kinds of timing requirements. Yeah, so if some applications need to execute in a very short time, then having we will see some examples in that area. So if you require that kind of a performance, then cloud computing has an issue, because there is there is a potential for a long round trip time that's there. Okay, so that's one of the things that needs to be as challenges in cloud computing. And the other issue that also exists is the issue of security and privacy, which is very important in the current ages, because there are attacks happening. Various mechanisms are utilized to attack various resources, various parts of the infrastructure, also thereby gaining access to some very important private information, and causing a lot of causing a lot of problems to cost, and issues that come up when there is a downtime of the whole cloud resource. So security is an issue. Security and privacy both are very important issues, and the issue arises because there are some concerns in terms of vulnerability to attacks, especially when the information is outside the firewall. Yeah, so if there are not proper steps followed by the cloud provider, and proper security mechanisms are not there, then your information has gone out into the network, remote network, and then you don't have any control over it, right? So if the cloud provider has not put in place the required mechanisms to ensure these aspects, then it becomes quite vulnerable to attacks, especially also because one of the as we already saw, one of the enabling technologies for cloud computing is virtualization, and there are these applications running on VMs, virtual machines, and there could be attack surfaces or attack possibilities that are there from one VM to the other, which typically there are the chances of that happening is very low, but there can be still a lot of as in the security field, it's called as side channels. So there could be some side channels that are exploited, which can enable these attacks possible, and that could be one major issue that you do not want to happen with your very critical or important data. So that is one thing. The other aspect is control, right? So in especially in public clouds, you don't have any control over the way things are done. So you don't have any control over how your data is handled, how the set of applications that you want to execute are executing. So the control aspect is something that is absolutely not in your hands in terms of cloud computing, um, unless you are willing to do something like a private cloud. or in some ways, the hybrid cloud. So other very important, apart from performance, security, and privacy, the other very important part, which is quite detrimental to the whole set of advantages that cloud computing provides, is the bandwidth cost. Yeah, so now assume that there are these different, millions of users. They want to use the services provided by a cloud provider, and they are sending data. They are sending their set of data to the cloud for the cloud to work on it. Now that incurs a lot of cost. Yeah, so every user has to pay for the data that he or she sends, and also the amount of data that is handled at the cloud side, and the amount of data that goes into the network, all of it adds to the bandwidth costs. Yeah, so bandwidth cost is a very important phenomenon, which really has made the cloud computing quite challenging in the current era of IoT. So we'll kind of see the emphasis of this as we go along to the topic of edge computing. So reliability is also one aspect, although they try to make it very reliable by having redundancies in place, having the executions hosted on multiple nodes, so that if one fails, the other is still there is still a result from the other. But it still may not be available 24/7, and we have seen in a lot of instances, like in especially it happens in the US, where there are some days where there is some kind of off a sale offer that's going on due to some festive season, and suddenly the entire thing, the whole service stops because of the large amount of traffic that's going into the system. So the reliability is definitely an issue. So you cannot always ensure that cloud computing will be the services of cloud computing will be available all the time of the year. So these are some of the challenges that cloud computing has. So now let's get into some motivations on having this background on cloud computing. Let's see how some of these aspects do not really sit well when you're going into this IoT era. Yeah. The emergence of IoT is one of the important events that has happened in the last decade, and things are kind of moving forward in a quick pace. So you can see that in 2003, this is data that is collected from Cisco document. So in 2003, there was this the number of connected devices were about 500 million, and the number of the world population was about 6.3 billion. Yeah, so here the world population was some orders of magnitude higher than the connected devices. Now at some point in time here, around 2005 2006, it the scales tipped, and the number of connected devices became more than the number of people in the world. So that's now very significant. Yeah. So coming to 2010, you can see it's kind of become double. So in about 4 years from when the number of connected devices became just a little bit more than the number of people, to the time to 2010, when it that's just a span of 4 years, and it became twice the number of almost twice the number of people in the world. Yeah. And then this gap is kind of increasing pretty fast now. Yeah. So now it's about in 2015 it was about 3.5 times, and in 2020 the numbers seem to be 6.5 times, around very close to 7 times the number of people. So what does this mean? So this means that now it's not just the user who is trying to connect to the cloud. There are if you from your previous lectures, you would have understood this concept of IoT, right? So IoT means anything can now be connected to the network. So if there are if practically anything can be connected to the network, then and if you're seeing these connected things or devices increasing in this progression, then you see that it's really going to go very upward, and number of users is not the determining criteria now. It's the number of connected devices. Yeah. So if there are like 50 billion devices plus the users that are connecting, of course, I mean, this is the worst case scenario, that all of them connect at the same time. But you can very well imagine this kind of scenario happening sometime later. Yeah. So when these many number of entities are trying to connect and send their data to the cloud, that's not what cloud was designed for. Yeah. So it was not the very inception of cloud was not did not happen keeping in mind the IoT scenario. So IoT scenario happened later, and cloud is trying to catch up to that scenario, and there are various things that are being done. So therefore there is a challenge that's there because of the sheer magnitude of the number of types and number of devices and the different kinds of devices that are trying to connect to the cloud. So that does not stop, right? I mean, internet of things, and then there is internet of everything, right? You could have people, you could have non-living things, everything is now connected, and everything is trying to send some message across. Yeah. So the emergence of this phenomenon of internet of things has really made it quite challenging for the way the systems were designed for cloud computing, the way resources have to be managed on the cloud, and the way things have to be processed. So the way data has to be handled needs to be taken care of uh, uh, with a lot more um, uh, newer technologies than just what cloud provides. Yeah. So that's one of the challenges that we have. I will look at some of these challenges, and maybe I'll stop after going through a couple of slides. I'll stop for some time to see if there are some questions, and after that, I think we can take a break and then come back and look at the edge scenario. As now you can see, the cloud is facing some of these challenges that we kind of hinted upon in our previous slides. So there is the volume challenge. Yeah, there is a lot of data that's coming because there are a lot of entities that are connected now. Um, one of the data points that's there is that when cars start getting connected, I mean, of course, in lots of places cars are already connected fully, and they are also in some places they're also almost like autonomous, but if there is this fully autonomous car that's there, and there are a lot of sensors that are placed within these cars, the amount of data that it generates is very huge. So it's in the order of GBs per hour or something. I don't exactly remember the figure, but it's a very high value. If you have to deal with that kind of data that's coming from just one device, one device, which is the car in itself, that's a lot of data that you're getting, and you have to make sense out of the data, because these sensors are not there inside the car just for the sake of putting it there because it looks good and you're getting some data. But there needs to be some sense made out of it. There needs to be some processing that needs to be done, and imagine that all of this processing has to happen over the cloud. So which means every car needs to send that much data to the cloud, and that's going to be a huge challenge. Yeah, it's not feasible to do that. So that's one of the very major challenges that cloud computing has. Of course, as we already know, these end nodes or devices are not anywhere proximally near to the cloud or the data center, and that could incur high latency. And again, taking the example of a car, there could be some uh, services or some functionality that it wants to execute. um, um, I mean, typically, currently, the cars have not still. Um, there are no scenarios in cars still that people have. Although people have identified scenarios inside the car, and we will look at one such example, but still people stay away from some of the critical functionalities of the car, because car is a safety critical system, and you do not want any untoward incident happening, right? So if things don't happen at the right time, things can get really catastrophic in a car scenario. So high latency is one of the issues which a real-time scenario like a car cannot really tolerate. Yeah, any such device that needs a real-time uh, thing, that it cannot be done using the cloud computing model. One other example could be like your monitoring. Let's say some fire breakout in a house, and you want to basically send that information and get back some response quickly. Yeah. Now, if understanding that there is such a thing, and the result has to happen, the whole processing of the data and inference of that data has to happen by going to the cloud and then you're coming back with the inference, then that could cause a lot of delay, and of course that also affects the subsequent help that you get from the fire department. So there are some situations where high latency is completely not accepted, and but there could be some scenarios, some applications where it's okay to have some latency. Like let's say you have some application like monitoring quality of air at some location in the city, yeah, and here and you want to make some inference based on that. So you're collecting data and you're making some inference of how does the quality of air change based on some activity that's happening in the city. So now here it's not really necessary for you to get the inference quickly. Yeah, you don't you collect data, you process it, and then you come up with some inference that yes, that activity is causing the air quality to deteriorate, and then you take decisions as to policy decisions as to whether what needs to be done to set it right. So that in such scenarios latency is not an issue. So so there uh, so there are scenarios like this which are not really which do not require real time constraints, where it is okay to suffer some latency, go over the cloud and then get back your results. Yeah, so there are multiple scenarios. Based on the scenario, uh, it could be a challenge to use cloud for your application. The other aspect is the transportation or communication cost. So large amount of data going over the network is a challenge in itself because of the costs involved with it. Transmitting that much amount of data is not does not come for free. So there is this cost involved, especially in the case of as I mentioned, in the case of the car. If you want to keep transmitting that much amount of data, that's going to incur some cost for you. So that's not something that's advisable. And resiliency is also something that's not always practical. um, Especially let's say you're looking at some scenario where there is no way that the remote node which needs to do some operation and send you some result just goes down for some time. So a cloud, it can happen. Yeah, you're not going to have resilient I mean, although there are mechanisms that and techniques that are put in place so that the resiliency is maximized, but that does not guarantee that it's going to be 100% resilient. Uh, so for some scenarios you may not want to take that chance. Yeah, so resiliency is also an issue that some scenarios you may not want uh, to affect your execution. And so these are some of the challenges that cloud computing has. I will stop with this slide. I'll just go through this slide and I'll stop here because this is the motivation to why we need edge computing. And the reason being, as I already mentioned, there are a lot of devices that are currently connected, and obviously the emergence of IoT has made that possible. The data, so one of the data points that is available says that by 2025 these many devices will generate something like 79.4 zettabytes of data. That's 10 to the power of 21. So that's a lot of data, and that actually would require something like 1,000 data centers. Yep. So that's not a very a positive scenario, right? I mean, it's handling this much data is very challenging, and over and above that, you have the cloud computing characteristics that we just saw, which is a high latency uh, scenario with due to the location of where the end device is and where the cloud node is. There is a centralized model of computing, right, in the cloud scenario. So because of the centralized model of computing, there are scenarios where the cloud node could just be non-functional, and then you don't have any other way of executing your required services. One other important aspect that cloud computing lacks is the location awareness. Yeah, so assuming that you send some you want some service to get executed for some purpose, cloud does not have automatically there is no location awareness that it has. It's just getting some data, executing it, and it does not have information on what is the situation in the nearby environment from where that device is requesting for a service. Yeah, so that information is not something that cloud computing can leverage, which is possible in lots of applications. So location awareness is not something that's there. The other important aspect is cloud computing. Absolutely, there is no support for mobility. So it becomes very challenging for some mobile node in the environment to reach out to cloud and try to execute some service. Yeah? And as we already discussed, it's there is vulnerability to security attacks. In short, summarizing the main three aspects that kind of motivate from moving from a cloud computing model to something little bit more distributed is are these three: the volume of data, the latency that a data experiences, and the bandwidth. Yeah, so these three aspects do not fare well in when we are looking at cloud computing kind of model. So with this, I think I will stop now, and if there are some questions until now, we can take that, and we can break for lunch and come back later.
Yeah, participants, feel free to unmute and ask the question.
Yeah. So, am I audible?
Yeah, Vaishali.
Yes.
Yeah.
Yes.
Good afternoon. Thank you so much for a detailed insight. It was really clarifying to understand how cloud computing works, sir. So, I am working in the field of IoT security, and I would like to understand that as a person who's doing research in IoT security, we know that there are many security issues, and we do understand that the resources available in an IoT device is limited. So we know that if I want to run some high-end computations like machine learning or deep learning on an IoT device, it's practically not possible, considering we don't have that much computation power available. And that is when we take help from cloud computing. But the question is, when we are trying to secure the IoT device, but we are going towards cloud computing, which itself is not 100% secure. So, is it not a trade-off that whether the security is increasing in a like, is it actually increasing, or it's like we are thinking it's increasing, but it's adding to more vulnerabilities in the system?
Yeah, so that's a very good question. If I summarize your question, you're asking whether I moving towards an IoT IoT based scenario, and maybe a more distributed scenario. Are we doing any better in terms of security? Because the cloud model itself was not entirely secure. So are we doing better in terms of security? Yeah, that was your question, right?
Yes, sir. Yes, sir.
So yes, of course. So there are limitations. There are a lot of issues that are added because now these devices are these different devices are points of attacks, and that increases the attack surfaces. But one of the important aspects that is, and of course there are a lot of other aspects that you mentioned, like executing machine learning algorithms, which in itself is a very important area that is being talked about now, how to execute machine learning, deep learning algorithms on these devices, edge devices, and how that brings into picture a lot of security issues. Given that it definitely is an issue that IoT devices are going to open up more security vulnerabilities. But the important aspect that needs to be kept in mind is that these are still distributed devices, and although of course they are connected, and if there are if some part of the network, if some part of the system is connected to this IoT device, the attacker may be able to access some other devices in the network and then cause some issues. But one thing that one thing that happens because of having these end nodes is that uh, things are more distributed, so it's more easier to handle the security issues that are there, rather than things being centralized at one location, and then and if some attack happens there, then it becomes completely it creates issues in terms of addressing them, the costs involved there, and of course the time taken to handle that. So if there are mechanisms in place in the IoT devices such that or the network of IoT devices such that things can be localized, uh, even if some attack happens in some device in a particular location, uh, the the idea is that the propagation of that to a large part of the network can be limited. Yeah. So of course this is not this is not something that has been done and dusted. There is still a lot of work that needs to happen in this scenario, because as you rightly mentioned, the IoT devices have their constraints in terms of resources. So we have to take those resources into those resource constraints into picture while designing appropriate security mechanisms. So there are some lightweight security mechanisms that are coming into you know people are trying to develop even to run in things like UAVs, and because UAVs also have issues in terms of resource constraints. But people are coming up with lightweight mechanisms, and that will try to limit the attacks that are possible. And also, I think there needs to be some concerted effort in terms of having mechanisms that will limit the propagation of the attacks towards more number of devices in the networks. Yeah, but that's an interesting question, and of course, there is no one answer to it. I think there still is a lot of work that needs to be done in that area.
Sure, sir. Thank you. Just one more question. Can I ask, ma'am?
Sure, sure.
Yeah, please.
Yeah, so it's also related. So when we talk about cloud, I personally, as I understand whatever I've read, is that whenever you plan to use cloud computing, you are actually trusting the service provider to a great extent. So when that trust factor comes in, the question comes about privacy issues. So if we are having a network, let's say IoT devices are connected, and then there's an edge layer where gateways are there, and then we are finally connected to the cloud somewhere. So the question over here is that when we are blindly trusting the, like I'm saying blindly trusting because we are giving a lot of access rights. They can access our MAC addresses, they can identify our devices. A lot of privacy is compromised when we trust that particular service provider. So the question is there a mechanism in which the user or the person who's deploying the network, the IoT network, has some sort of privacy control mechanisms available? Because if everything is accessible to the service provider, you are highly vulnerable in terms of your privacy being compromised.
Yes, so of course, privacy. There are a lot of mechanisms that are exploited where we can try to have privacy. Yes, a lot of privacy information concealed. So there are various mechanisms in the area of privacy that people have tried to or people are still working on. It's still a very ongoing field of research. So there's a lot of work in this area, and privacy definitely in term for IoT networks. Even if I may say, there are middlewares that are deployed, which have these are standard based for IoT standards, and they have some privacy control mechanisms that the middleware implementations need to have, so that there are accesses given based on the based on whoever is trying to access, and based on the permissions, and if there is some data that needs to be concealed, then that is something that is taken care of. So yes, there are some mechanisms that are happening both from the, I think, privacy algorithm point of view, and also in terms of these middleware layers that are coming up in the IoT standards domain.